Okay, so today we're looking at SOHCAHTOA again. Now, it follows a very similar pattern to what we were doing before. So it's very, very similar to what we were doing previously. However, the difference is that we're trying to find out what the missing angle is this time. So I'm just going to put a little part in here. So the title of today is Trigonometry, SOHCAHTOA, Missing Angles. There's something that you need to know to find the missing angles, and that's the inverse of sine, cos, and tan. Let's just write that down first of all. We need to know how to find the inverse of sine, cos, and tan. Let's change that to sine of sine, cos, and tan. So we know that if we've got sine of something, let's write some of these down now. So if we've got sine of something, so sine of theta, let's say, the inverse of that, to get rid of the sine, would be sine to the minus 1. Now, I'll show you where that is in a second, and we'll talk about this in a second. If I'm doing cos of theta, the inverse of that is cos to the minus 1 of something. And the last one, tan of theta, the inverse of that is tan to the minus 1 of something. And we'll talk about that in a second. But that's where we start off with this. So let's get this first question down then. Hopefully you've all got that down. Let's have a go at this first question. Now, it follows a very similar pattern to if we were finding the sides. However, we need to do a last little step at the end. It's ever so slightly different, okay? So, get this one down as example 1. I'm going to do example 1, example 2. I'm going to let you have a go at some yourself, and then we're going to continue from there. So the first thing we need to do, always, we need to follow those first steps, don't we? So we label the sides first of all. Once we've labeled those sides, we write down our need and got list. Then we highlight SOHCAHTOA. And then once we've done that, we use the triangle to work backwards. So we'll talk about all of that in a second. So the first thing I need to do is to label my side. So we know that opposite the right angle here is the hypotenuse. We know that opposite the angle here is my opposite. And we know that in between the angle and the right angle, so in between here, is my adjacent there. So that's our first part. The next thing we need to do is our need and got list. Okay, so what do I need? Well, this time here, this is ever so slightly different. This time here, we need our angle. And we know that our angle is called theta. So we need theta. And what we've got is we've got the opposite, and we've also got the adjacent. So we're not using this time h. So I've got the opposite, I've got the adjacent, I'm not using h. So the next thing we do in our list of things that we've done already is we write down SOHCAHTOA, making sure the middle letters are above, and then we highlight what is in our need and got list. So we've got SO, we've got CA, and we've got TOA. And then I highlight what's in my need and got list. So I'm going to highlight, well, O is in my need and got list, so I highlight O. And A is in my need and got list, so I'm going to highlight A. Now, this is the question that some people struggled with last time. The question was, which one do I use then? And it's the one that's got two things highlighted. So it's going to be this one here, like so, the tan one, the TOA. Now we know. Okay, so we know that we're using TOA. So we know that stands for tan. So tan of theta is equal to O is at the top over adjacent. And then we draw a triangle like so, like this. And then we cover what we need. Now, the thing I need in this one is the angle. So the thing that I'm covering is this here, the tan of theta, which means gives me my formula. Now, notice the O is over the A. So I've got tan of theta is equal to opposite over adjacent. Tan of theta is equal to opposite over adjacent. So we picked tan because the two are highlighted. And now what I need to do is I need to substitute in. So I know that tan of theta is equal to my opposite, which is that 8, over the adjacent, which is 11. So that's the kind of bit we've done already. Now, the thing that we haven't done is here, the problem we've got is we don't want tan of theta. We just want theta on its own. So I need to get rid of that tan to get theta on its own. Now, the inverse of tan is tan to the minus 1. So both sides, to get rid of this tan here, I need to do tan to the minus 1 and tan to the minus 1. And that leaves me with this. This is the last part, which is new. Theta is equal to tan to the minus 1 of 8 over 11. Theta is equal to tan to the minus 1 of 8 over 11. So let's type that into my calculator, and I'm going to show you where that is. Now, you can see tan here on the right-hand side. Now, tan to the minus 1 is just above that. So to get that, you've got to press the shift, which is in the top left. So shift here, press the shift button, and then tan to the minus 1 there. I'll just show you that again. So the shift, which is on the top left there, so shift, and then press tan, because tan to the minus 1 is above it. You'll see it in green, it's really small. So tan to the minus 1 of 8 over 11, like so. And there's your answer. They want it to one decimal place. So theta, my angle, is equal to 36.0 degrees. There we go. It is tough, that there's loads going on. You've got to know all of those individual steps, and the only way you're going to get to know this is to practice it. I'm going to do one more, and then I'm going to ask you to have a go at some yourself. So that was example 1. We're going to have a look at example 2. I'll do one more. It is different. It's very similar, but it's different. You've got to follow the same steps, but it's going to be a different trigonometric ratio this time. So give you a second to get that one down on the left down, and then we'll do example 2. So let's have a go at this one on the right, sorry. So, same as always, the first thing that I need to do is I need to label my triangle. Now, it's different now, isn't it? So opposite my right angle here is my hypotenuse. Opposite my angle here is my... So opposite my angle here is my opposite. And then the one between the angle and the right angle is my adjacent, which is this one here. So then I need to do my need and got list. So I'm going to need / got. So what do I need in this case? Well, I need the angle, which is theta, or x. And I've got my adjacent, and I've got h. The one that I'm not using this time is that opposite there. So then I write down my word, which is SOHCAHTOA. So SOHCAHTOA. And I highlight everything which is in my need and got list. So the things that are in my need and got list this time are A first, and then the hypotenuse, so I'm going to be using this one here, which is CA, which stands for cos. So I draw out the triangle for this, which is cos of theta is adjacent over hypotenuse. And then I cover everything that I need. So in this case, I need cos of theta, which leaves me with that there. So if I cover up cos of theta is equal to adjacent over hypotenuse. A over h there. So I've got cos of x or theta is equal to my A, which is 3. So this one here. My A, which is 3. Over my hypotenuse, which is 10. Now, the last little stage, and this is the new step, isn't it? I don't want cos of theta. I just want theta on its own. So what I need to do is I need to get rid of that cos next to the theta. And I do that by doing the inverse of cos, which is cos to the -1. So that leaves me with theta is equal to cos to the -1 of 3 over 10. So I type that into my calculator. So remember, we're doing cos to the -1 this time. Now the cos to the -1 is above the cos button. I've got to press shift first. So shift cos to the -1 of 3 over 10. Close that bracket. Remember, it's cos to the -1, so I'm doing the inverse, which gives me here 72.5 degrees. Done. Super. All right, now this isn't easy. This is tricky, okay? There's loads of different steps. You've got to label your triangle first. You've got to write down your need and got list. You've got to highlight SOHCAHTOA. Okay, then you've got to know how to use it. All of it is quite tricky. All right, have a little go at this one on the left-hand side yourself. Have a little go at this one on your left-hand side yourself. And then So I'm going to start going through it now. So if I look at this, the first thing I always need to do is to label my triangle. So opposite my right angle is my hypotenuse. Opposite my angle is my opposite. And between the angle and the right angle is my adjacent. Okay, that's my first step. The next thing I need to do is my need and got list. So I need, in this case, the angle. And I've got, in this case, I've got the 5, which is my opposite. And I've also got the H, which is, 11, which is the H. So then I write down SOHCAHTOA. So SOHCAHTOA. And I highlight everything which is in my need and got list. So O is in there, highlight O. H is in there, highlight H. So in this case, which one's got 2 things highlighted? It's sine there, isn't it? So I write down the triangle for sine, which is sine of theta is equal to opposite over hypotenuse. So then I substitute in everything I've got. I know that I need theta, so I cover sine. So it's going to be sine of theta is equal to the opposite, which is at the top here, opposite over hypotenuse. I know what my opposite is, it's 5. I know what my hypotenuse is, it's 11. So sine of theta is equal to 5 over 11. And then the last little part, I need to get rid of that sine by doing sine to the minus 1 of the other side. So I'm going to take this over to the other side. So theta is equal to sine to the minus 1 of 5 over 11. So let's work that out on the calculator. So shift sine to the minus 1 of 5 over 11. So theta is equal to 27.0. Brilliant work to everybody who's got that right. It's impressive that. It's hard that. It comes towards the back end of that foundation paper. Okay, so have a little go at that one on the right-hand side this time. Same process. Label it first. Write my need and got list. Highlight SOHCAHTOA, and then do all of the stuff. Have a little go at that one on the right. But some people have already got this already. It's very impressive. I'll give you another second or so, and then I'll go through it. Okay, let's start going through it then. So first things first, have to label my triangle. So opposite the right angle is my hypotenuse, which is there. Opposite here is kind of pointing to it, isn't it? Opposite the angle is my opposite, which is here. And then between that angle and the right angle is my adjacent, which is this one down here, which is at the bottom. So once I've done that, I need to write down my need and got list. And I need here my angle, which is theta. And I've got my opposite here, which is O, and my adjacent, which is 12. The ones I'm not using this time is the H. So I write down the word SOHCAHTOA, SOHCAHTOA, and I highlight everything which is in there. So it's in my need and got list. So I highlight O, I highlight A, and you can see the one that's got two things highlighted is TOA, so this one over here. So then I write down tan of theta is equal to opposite over adjacent. And then I'm trying to find the angle, so I'm going to cover up tan of theta, which gives me tan of theta is equal to opposite over adjacent. I substitute in the things that I know. So tan of theta, is equal to my opposite, which is 11, over my adjacent, which is 12. And then the last little part is I need to get rid of the tan on the left-hand side by doing tan the inverse. So theta is equal to tan to the minus 1 of 11 over 12. So to type it into my calculator, it's going to be shift tan to the minus 1 of the fraction, which is 11 over 12 there, like so. Which gives me 42.51, but to one decimal place, that is equal to 42.5 degrees. Brilliant. So I know that we've done quite a lot of these. Okay, I'll do one more. I'll do another one. So have a little go at the one on the left-hand side. Have a go at it yourself first. I think it's important you do loads of practice on this. So have a little go at that one on yourself there. So I've just had a question asked, which will it always be to the minus 1? Now, the minus 1 is when we're doing the inverse of this. So if you're trying to find the angle, yes. It's always going to be to the -1. If you're trying to find the sides, then no, it's not, because you've already got the side on its own. So if it's an angle, you always do the tan to the -1, because you're trying to find out theta. And if it's a side, then you just use the tan, sine, or cos. So cos, sine, cos, or tan. Let's start having a go at the one on the left. So the first thing I always need to do is to label that triangle. Now this triangle's a little bit upside down, isn't it? So opposite that right angle is called my hypotenuse, always, okay? Opposite that right angle there. Opposite the angle is equal to my opposite. So opposite the angle y is my opposite. And then between the angle and the right angle is my adjacent there. So I then need to write out my need and got list. So need slash got. So the things that I need, as I need in this case, y, don't I? I need the angle theta. So my angle y, which is theta. The things that I've got, well, I've got my opposite over here, which is 3. So I write down my opposite here. And I've got my hypotenuse, which is 11, which is h. So the one I'm not using this time is a. So I then write out SOHCAHTOA. So SOHCAHTOA. And I highlight everything which is in my need and got list. So the things which are in my need and got list. Okay. Sorry. Okay. So I highlight what's in my need and got list. So I'm going to highlight O. I'm going to highlight H, which means that I'm going to be using SOH, which is sine is equal to opposite over hypotenuse. So sine of theta is equal to opposite over hypotenuse, there like so. So then I'm trying to find the angle. So it's going to be sine of theta is equal to opposite over hypotenuse. So I sub in what I know. So sine of theta is equal to the opposite, which is 3, over the hypotenuse, which is 11. And then to get rid of that sine, I need to use sine to the minus 1. So theta is equal to sine to the minus 1 of 3 over 11. I'm going to type that into my calculator. So shift sine to the minus 1 of open bracket fraction 3 over 11. Close that bracket there. And it gives me 15.8. 15.8 degrees. All right, last one. Have a little go at the one on the right-hand side. Have a go at that one on the right-hand side yourself. The last one we'll do today. Have a little go at that one on the right-hand side. Okay, so I'm going to quickly go through that one on the right-hand side. We will have a go at some of these tomorrow ourselves. So labeled are triangles. So opposite the right angle is the hypotenuse. Opposite the angle is my opposite, and in between the angle and the right angle is my adjacent. I write down my need and got list. So the thing that I need is my angle, which is theta. And the thing that I've got is my opposite and adjacent. So I've got my opposite, I've got my adjacent. The one I'm not using is H in this one. So I write down SOHCAHTOA. So I highlight what's in my need and got list. So in this case, it's O and A. So I'm going to be using tan of theta is equal to opposite over adjacent. So because I want angle, it's going to be tan of theta is equal to opposite over adjacent. So tan of theta is equal to my opposite, which is 4, over my adjacent, which is 5. And then the last little part, I need to do theta is equal to tan to the minus 1 of 4 over 5. I'll do that on my calculator. Shift tan to the minus 1 of 4 over 5. So theta is equal to 38.7 degrees. Well done to all those who got it right. Okay, let's just check those answers.